Hello and welcome to Sybera. Today I would like to introduce you to programming with Sybera's EtherCAT Master Library. The hardware we need for this is a desktop PC or notebook with a Windows operating system. The PC must have an Ethernet connection with a Realtek or Intel chip. Programming with the EtherCAT Master Library can be done using various programming languages. These include Visual Studio C++, Visual Studio C#, CVI Lab Windows, Embarcadero C++, and Embarcadero Delphi. In the following, we will perform the programming using Microsoft's Visual Studio C++. After installation, the necessary header and library files can be found in the C ECT directory. Let's take a closer look at three files. The file EtherCAT contains all relevant structures. The file EtherCAT contains all exported functions. The file sha-ecatcore.lib is the library connection for the project. In the header file EtherCAT, we will now take a closer look at two structures. First, the EtherCAT param structure. This structure is mainly used for the functions of the high-level interface as a transfer parameter. Secondly, the station info structure, which contains a complete description of the settings for each EtherCAT device and enables access to the user data telegrams. In the header file sha-ecatcore, we find all function prototypes for programming divided into two main groups. The first group, the low-level interface, includes all functions for complete control of EtherCAT devices. The second group, the high-level interface, includes all functions for a quick start in programming. For our example, let's now look at the required core library functions of the high-level interface. In the next step, we create a new project for a console application in the Visual Studio IDE and select the appropriate target platform. We then import the necessary header and library files into the project. Our source code is now extended with additional header files. Global variables are simply declared for data exchange between the real-time task and the Windows application. Now the real-time task is implemented. Here, the station data is processed deterministically and updated at the set time interval for the period. The EtherCAT param structure defines the time grid of the update cycle with the elements period and sync cycles. The SHA EtherCAT create function now implicitly generates the station list of all connected devices. If the function was successful, the output elements are stored in the global variables for further use in the real-time task. Once the last global element has been assigned, the init flag must then be set and cyclic operation in the real-time task must be enabled. Now the stations are activated with the SHA EtherCAT enable function. The function now takes over the device configuration stored in the EtherCAT file, initializes the devices in the station list, and switches them to operational mode. Cyclical EtherCAT operation begins. Since both real-time task and Windows threat have access to the station list, we can output all enumerated station names. In our example, the input data is output and the output data is updated in a loop of Windows thread. Now we generate executable code and start the compiler and linker. If the process was successful, we start the program. I hope you enjoyed the presentation. Would you like to find out more? Then come and visit us. We will be happy to answer your questions in a personal meeting.